The masses of 80 parcels sent out by the garden center are given in the table. The parcels which are 12, they have the mass range from 0 to 2 kg, and likewise the parcel having the mass range 2 to 4 kg, they are 18 in number, and likewise given in the table. One parcel was chosen at random and not replaced. This is experiment without replacement. A second parcel was chosen at random from the remainder. Giving each answer as a fraction in its lowest term, find the probability that both parcels were chosen from the group 6 to 10 kg. Let's call this group 6 to 10 kg G, and the groups other than this are called G complement. Better way to find probability both are in two events is to draw the tree diagram like this. So G stand for group and G complement stand not in that group. If you pick the first parcel from this group, the probability will be 20 out of 80. And obviously the probability of those which are not in that group will be 60 over 80. Once you picked a parcel out of 80, remaining parcels are 79. So I wrote 79 in the denominator at the top of the each barrage. Once you pick a parcel from the group, so no remaining total are 79 left, and the parcel in that group which were 20 before, now they are 19. But here we still have 60 parcels which are not in that group. And here once you picked a parcel, if you pick the parcel first from not in that group, so we have still 20 in that group. And obviously it will be 59 because we have already picked G from G complement. So we have, there were total, now we have 59. Once we have drawn this tree diagram, probability tree diagram, now we have to find the probability both parcels were chosen from this group. Same. So we will multiply both of the probabilities. So after simplification, it is 19 over 360. Next, we have to find the probability that one parcel was chosen from the group, that is 6 to 10 kg group, and the other parcel was not chosen from this group. Here you can see that. So we have two options. Either the first one from the group and the next one was not from the group, or first one was not from the group and the second was from the group. So we have two options. So the probability of the first one, that is G into G complement, is 15 over 79, and for the probability of the second option is also 15 over 79. So when we have two different options, we have to add them. So just adding these two probabilities, the final answer is 30 over 79. An ordinary unbiased die has faces numbered 1 to 6. Sarah and Terry each threw this die once. Expressing each answer as a fraction in its lowest term, find the probability that Sarah threw a 7. As there is no 7 in the numbers, so the probability will be 0 over the total numbers, that is 6. So it is 0. And find the probability that they both threw a 6. To find the probability that they both threw a 6, it is better to draw a tree diagram. So in the first case, which is the case of Sarah, suppose Sarah did first. So there are two options: either she threw 6 or she may not threw 6. In the second case, which is about Terry, so Terry has also two options: either he threw 6 or not 6. So I have written the probability on the branches. So probability of 6 is 1 over 6 because there is 1 6 out of total 6 numbers, and obviously if it is 1 over 6, 1 from 6, so it will be 5 over 6. and the sum of these two should be equal to 1. 1 over 6 plus 5 over 6 is equal to 1, that is 6 over 6. In the same way, the probability of throwing 6 in case of Terry is also 1 over 6, and not throwing 6 is 5 over 6, likewise. Now we are interested to find the probability that they both threw a 6. So there is only one option in which they both threw a 6, 6, 6. So the probability will be 1 into 6 times 1 into 6, that is 1 over 36. Find the probability that neither threw an even number. Now we have two options, through an even number or throwing not an even number. Let me draw again a tree diagram. There are 3 even numbers out of 6 numbers, so probability of even number is 3 over 6, and the numbers which are not even number, those are also 3 out of 6. So the first case is the case of the Sarah, and the second case is the case of, that is, suppose first Sarah threw a die and then Terry threw a die. You can also write Terry first and Sarah second, and you will get the same answer. So the probability that neither threw an even number, look at this tree diagram, we have only one option in which neither have thrown the even number, not even number by Sarah, not even number by Terry, and this is the only one case. So the probability is 3 over 6 times 3 over 6, and after simplification it is 1 over 4. Find the probability that Sarah threw exactly 4 more than Terry. It is better to draw in this case the possibility diagram for 2 events, or you can also draw the list of the numbers for this case as well. This is a possibility diagram. Suppose the first throw is from the Terry side and the second throw is from the Sarah side. Therefore, the first coordinate represents Terry and the second coordinate represents Sarah. So we have to pick those coordinates in which the Sarah, the second coordinate, is 4 more than the first one. So out of all these 36 options, we have only 2 in which Sarah has 4 more than the Terry. The one here, if Terry threw 1 and Sarah threw 5, so the Sarah has 4 more than the Terry. And second option is this, 2, 6, where Terry threw 2 and Sarah threw 6, and Sarah is 4 more than Terry. So we have, out of these 36 outcomes, these 2 outcomes are favorable. So therefore probability is 1 over 18. The ages of sample of 40 students was recorded. The results are given in the table. And the number of students there are 7 students who has age group from 8 to 10 years, and likewise. One student is chosen at random from this sample of 40 students. Write down the probability that this student is under 8. You can see here we have no student in this table which is under 8 because the table starts from 8 years. So the probability is 0. 0 over 40, that is 0. Find the probability that this student is over 16. You can see here the student whose age is more than 16 and up to 19, they are 6 out of 40. So it is 6 over 40. After simplification, it is 3 over 20. A second student is now chosen at random from the remaining 39. So look here, the student was 40. Now it has become 39. So this is experiment without replacement. Calculate the probability that one student is over 16 and the other is not over 16. So let me draw a tree diagram to better understand. So there are 2 groups. One is from 16 and the second group is not over 16. Let me call those who are over 16 group. They are called in G, and those who are not over 16, they are G complement. So this is the first pick and this is the second pick. Students who are over 16 are 6 out of 40. 6 over 14, obviously it will be 34 because out of 46, and these will be 34. Once you picked 1 in the first case, so there will be 39 left. Now I have written 39 total number of students left in the denominator. Once you have picked the first student from the group over 16, so they left 5 now. So if it is 5 out of 39, it will be obviously 34 out of 39. Similarly, if we have picked from the group which is not over 16, they were before 33, now they will be 39. Obviously it will be 6 over 39, because sum of these two will be equal 1, and some of these will be also 1, and some of these will also be 1. Now we have to calculate the probability that one student is over 16 and the other is not over 16. That is, first is in the group and the second is not in the group. As we have two paths or two options in which one is from the group and the second is not in the group, these are these two one, and just finding both of them. When we have two different paths, we have to add the probabilities. So just adding these two will give us answer 17 over 65. Emma noted the number of letters in each of the 25 words. In an examination question, the results are given in the table. 2 letters were repeated in 2 words, and 3 letters were repeated in 6 words, and there are 4 letters which appeared in 5 words. Emma choose one word at random from the 25 words. Find the probability that this word had 5 or 6 letters. The number of words which have 5 letters, they are 5 words out of 25, and the words which have 6 letters, they are 5 words out of 25. So the probability of 5 letters, the probability of words which have 5 letters is 5 over 25, and the probability of the words which has 6 letters, those are 4 words, 4 out of 25. When there is a word or, we will add the probabilities. So the final probability will be 9 over 25. Find the probability that this word has fewer than 9 letters. So you can see here all the words have fewer than 9 letters. So they are 25 words out of 25. So 25 over 25. That is 1. Peter choose one word at random from the 25 words. He then chooses a second word at random from the remaining words. So it is experiment without replacement. Expressing each answer as a fraction in its lowest term, find the probability that both words had 6 letters. So let's draw a tree diagram again. So there are 2 cases. The word will have 6 letters or it will not have 6 letters. 6 and not 6. So there are 4 words which have 6 letters. So the probability is 4 over 25. And obviously which has not 6, there will be 21 over 25, because some of these will be 1. In the second one word, so we have already picked one word, so 24 left because it is experiment without replacement. And out of these 24, so we have words which are 6 letters, 3 left because we have already picked one in the first instance. So this will be 21 over 24 because the sum of these two will be 1. And in the similar way, so we have 20 left words which have not 6 because we have already picked one in this case. So just filling all the probabilities, we have to find the case in which both have 6 letters. So this is only one case, and that is this one. So just multiplying the probability, the answer is 1 over 50. Now we have to find the probability that one word had 2 letters and second has 4 letters. And this is again experiment without replacement. So the word which has 2 letters, they are 2 out of 25, and those which have 4 letters, they are 5 out of 25. We should have a third branch as well, in which we are not interested both in 2 and 4. And its probability will be 5 plus 7. So 25 minus 7 is 18. But we are not interested in this branch. So we will not continue this. So this is experiment without replacement. So once we picked a word, so we have left 24. And out of these 24, we have already picked the word which has 2 letters. So now we have left only one such. And words which have 4 letters, we haven't picked that. So they are still 5. So it is 5 over 24. Be careful here. The sum of these will not be 1, because we have not considered this option. And there is no third branch here. So if we put a third branch, then the sum of all the probabilities of all 3 branches will be 1. In this case, we have to pick 2 again, but we haven't picked 2 in the previous instance, so they still have 2. And here we have already picked 1 in the previous instance, so they will be 4 over 24. So it is 6 over 25, it is also 6 over 24, 6 over 24 and 6 over 24. And it is 7 over 25. Find the probability the one word is 2 and the second is, and the other is 4. We have 2 such options. The first is 2 and the second is 4. So now we have to multiply the probabilities and then add them. So it is 1 over 60 and 1 over 60, because we have 2 different paths. When we have 2 different paths, add the probabilities, it is 1 over 30. A bag contains 5 balls numbered from 1 to 5, and another bag contains 6 balls numbered from 1 to 6. One ball is drawn from each bag. Find the probability that one ball is numbered 1 and the other 6. So there are 2 bags. The first bag contains 5 balls. So the probability of 1 is 1 over 5, and the probability, as there is no 6 ball, so its probability will be 0 over 5. We are interested in only 2 balls, 1 and 6, so we have 2 branches in our tree diagram. In the second ball, there is only one ball, number 1, so probability is 1 over 6, and there is only one ball, number 6, so the probability is 1 over 6. And now we have filled the probabilities, and we are interested only in that option in which the one ball is number 1 and the second ball is number 6. So we have 2 options. We have just multiplied the probabilities and then we add them. So the first one will be 1 over 30 and the second will be 0, because the probability, this one is 0. When multiplying 0 with any number will give us answer 0. So the final answer is 1 over 30. Find the probability that both balls have an odd numbers. Let's draw the tree diagram again. So we have 2 options, either ball is odd or not odd. So this is our tree diagram. In the first bag, there are how many odd balls? 1, 2, 3 odd balls out of 5. And there are 2 balls which are not odd out of 5. In the second bag, there are 1, 2, 3 odd balls, but these are out of 6. And there are 3 not odd balls out of 6. So we are interested in both odd balls. So there is only one option. So by multiplying and simplification, the answer is 3 over 10. Both balls have the same number. So we can do this question by drawing the possibility diagram. These are the ball number in first bag and these are the ball number in the second bag. So these are the only outcomes in which both balls have the same number. So these are 1, 2, 3, 4, 5 and 6 into 5, 30. Out of 30 we have 5 balls in which both numbers are same. So the probability is 5 over 30. After simplification it is 1 over 6. The sum of the numbers on the ball is 9. It is good to draw possibility diagram again. Now we have to add the numbers on the balls. So as the sum is 9, so there are 3 possibilities. So ball number 3 and 6 will be 9, and 4 plus 5 is 9, and 5 plus 4 is also 9. So 3 out of 30, which is 1 over 10. A bag contained 5 red and 2 blue beads. Chris took 3 beads at random and without replacement. From the bag, the probability tree shows the possible outcomes and their probabilities. So he took 3 beads. So there are 3 steps in tree diagram. 1, 2 and 3. Write down the value of P, Q and R. As this experiment is without replacement, so in the first there are 7 balls. In the second case, the 6 ball left, and then the third case 5 ball will be left. So there will be 5 in the denominator. So this P is about blue. So we have picked 1 blue in the first instance, and there were 2 blues. So only 1 blue left now here. It is 1 over 5. Now it is about Q is about red. So we haven't picked any red in the previous 2 instances. So there were 5 red balls. So it is 5 over 5. And Q is 1. And R about blue. R is about blue. Look this path. Come this path backward. And there is 1 blue from here and 1 blue from here. There were 2 blues in total. So 1 picked here and the second is picked here. So no blue ball left. So it will be 0 over 5. That is 0. R is 0. Now we have to find the probability that 3 red beads were taken. And there is only one option. There are 3 red beads were taken. And that is this one. Now multiply these probabilities. 2 over 7. The first bead was red, second was blue and third was red again. So see these numbers, it is first, second, third. These are the order numbers. So we have to maintain this order. So first red, so it will be red, blue, red. So first is red, second is blue, first is red, second is blue and third is red. So we have to opt this path. Red, blue, red. Now we have to multiply these probabilities. So this will give us answer 4 over 21. 2 of the beads were red and 1 was blue. So there is no order fix here. So we can pick any order in which 2 beads would be red and 1 will be blue. It is 2 red, 1 blue. So we have only 3 options in which 2 are red and 1 is blue. This one and this one. Find the probability of each one and then add all these 3. So these are the working. Here you can observe a pattern. All have the same denominator 765, 765, 765, and all have the same numerator as well 245, 245, 245. So all 3 will have the same answer. Just calculate the one and multiply by 3. 4 over 21. Now multiply by 3. So the final answer will be 4 over 7. The speed of 50 cars being driven along a stretch of road were recorded. The table below shows the distribution of the speeds of the cars. The 4 cars have speed between 20 and 40 and 14 cars have speed 40 to 50 and like that. Find the probability that one car selected at random had a speed of less than 20 and there is no car which has speed less than 20. So the probability will be 0. Find the probability that one car had a speed more than 60 km per hour. So there are 10 plus 4, 14 cars which have speed more than 60. It is 14 over 15 and that is 7 over 25. There is a speed limit of 60 km per hour on this stretch of road. Two cars were selected at random. Calculate the probability that one car was breaking the speed limit and the other car was not breaking the limit. So we have to draw a probability tree diagram, and there are two possibilities that either car will break the limit or not break the limit. For the first car, it may break the limit, or B complement not break the limit. Breaking limit is 60 km/h. So 10 plus 14 cars have speed greater than 60. So they are breaking the limit. So 14 cars out of 50. So 14 over 50 are the probability of the car, those breaking the limit, and 36 over 50 will be those who are not breaking the speed limit, those who have speed less than 60 km/h. Now for second car, we also have two options. As we have selected one car already, so now we have total 49 cars left. And cars, those have broken the limit, they were 14. So one is already selected in this first portion. So we have left 13 cars here. And it will be 36 over 14 as the sum of these will be 1. So the sum of these also will be 1. Here we have selected car which has not broken the limit. So they were 36. So one is chosen here. So we have 35 here left. So as the sum of these two is 1. So it is 35 over 49. So it will be 13 over 49. Sorry, this is 14 over 49. In this case, we have two options. So one is the car breaking the limit and the second not breaking the limit, or the first car breaking the limit and second car not breaking the limit. So finding the probability of these two after multiplication and adding both of them, so the final answer is 72 over 175. The table shows the number of cars owned by each of 25 families. A family is chosen at random. Find the probability that it owns 3 cars. Be careful, right now a family is chosen at random. And this table is showing the number of cars owned by each family. So these are the family who own 3 cars. So these are 1, 2, 3, 4, 5 families out of 25 families. So the probability is 1 over 25, which is 1 over 5. Now 2 families are chosen at random. Find the probability that one family owns 2 cars and the other owns 4 cars. So in the first pick, either that first one will have 2 cars or 4 cars. In the second pick, so in the second pick also have either 2 cars or 4 cars. So out of 25 families, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 families have 2 cars. And only 2 families out of 25 have 4 cars. But once we picked the family, we have left 24 in the second choice. And out of these 24, so we have already picked the family which has 2 cars. So we have left 5 families now. So it is 5 over 24. And here the for 4 car family, we still have 2 families here which owns 4 cars. Here in this case, the families who owned 4 cars, they were 2. As we have already picked one, so we left 1 here. As here sum is 7, 5 plus 2 7. So 1, or it will be 6 here. 6 plus 1 7. As we have not picked any family which has 2 cars in its previous path, So there are still 6 families which have 2 cars. So it is 6 over 24. So here we have 2 favorable outcomes in which one family has 2 cars and other has 4 cars. Now we are going to find the probability, just multiplication, just adding these two, the final answer will be 1 over 25. Now a car is chosen at random. Before that a family was chosen. Now a car is chosen at random. Find the probability that it belongs to a family which owns 2 cars. Because we have to choose car now, so we have to count all those cars which belongs to family which owns 2 cars. So these are the two cars, 2, 4, 6, 8, 10 and 12. And the total cars are 48. So the probability is 12 over 48, which is 1 over 4. A fair 5-sided spinner is numbered using the prime numbers 2, 3, 5, 7 and 11. In a game, players spin it twice and add the 2 numbers obtained. Complete the possibility diagram. As players spin it twice, so in the first instance we can have 2 or 3, 5, 7 or 11. In the same way, in the second spin we will have these numbers. We can have these numbers either 2, 3, 5, 7 and 11. And player add these 2 numbers obtained in 2 spin. So I have completed the table. Find the probability that the total of the 2 number is a prime number. So the total outcomes are 1, 2, 3, 4, 5 and 5. 5 into 5, 25. These are 25 outcomes. And out of those 25, 1, 2, 3, 1, 2, 3, 6 are prime numbers. Therefore, the probability is 6 over 25. You can observe the pattern here. Find the probability that the total of the 2 number is a perfect square. Out of these 25, these numbers are perfect square. This is square of 2, this is square of 3, this is square of 4. These are 5 numbers, so probability is 5 over 29. After simplification, it is 1 over 5. In another game, players spin it twice and multiply the 2 numbers obtained. Without drawing another possibility diagram, write down the probability that this product is a prime number. And you know that prime number is a number which has only 2 factors, 1 and itself. If it has factor other than these 2, so that number will not be a prime number. And spinner has these numbers which are other than 1 and itself. And if you multiply these numbers, so the answer will have a factor more than 2 factors, 1 and itself, other than 1 and itself. So the product will not be a prime number. So here the answer is 0. So there will be no, the product of these number will not be a prime number. So the probability is 0. As prime number cannot have factors other than 1 in itself. The number these are written on the 6 cards. 2 cards are chosen at random without replacement to form a 2-digit number. The first card chosen shows the number of tens and the second card chosen shows the number of units. So now we have to express in the simplest form the probability that the 2 cards show a number greater than 20. To show a number greater than 20, the first card should be 2 or greater than 2. And all the 6 cards are 2 or greater than 2. So the probability will be 6 out of 6. And next we have to pick the second card. So when there is a word and, we have to multiply. Now we have 5 cards left because we have already picked 1 card, and to form a number greater than 20, the second card should be either 1 or greater than 1, and all the cards are greater than 1, and we have only 5 cards and all the 5 cards will be greater than 1. So the probability of the second card is 5 over 5, which after simplification will give answer 1. Now we have to find the probability that the two cards show the number 33. So the probability of the first card that it is 3, and again the probability that the second card will also show 3. You can see there are only 3 card number 3 out of 6. Therefore the probability of the first card is 2 over 6. And we have to pick the next card, so it is word and we have to multiply. We have 5 cards left, and now we have to pick again the card number 3. One card number 3 is already picked, so we have only one card left. So it is the probability 1 over 5. Now after simplification, the probability of number 33 will be 1 over 15. Now we have to find the probability that the two cards show number 43 or the number 32. For the number 43, the first card should be 4. So there are 4 cards out of 6. So the for number 43, the probability of the first card will be 3 over 6, and the probability of the card 3. So we have 5 cards left because the experiment is without replacement. And out of these 5 cards, how many are card number 3? Because we haven't picked any card number 3, so we have still 2 cards. So the probability will be of the second card is 2 over 5 for the number 43. Now we have to find the probability of 32. So in this 32, the probability of the first card, which is 3, will be 2 over 6 because there are 2 card number 3. And to find the probability of 2, so we have, because the experiment is without replacement, now we have 5 cards left. In these 5 cards, there are how many 2 cards? There is only one card number 2. So 1 over 5. And because there is a word or between them, so whenever there is a word or, we add, we use plus sign. So after simplification, the final answer will be 4 over 15. A bag contains 5 balls, of which 3 are red and 2 are blue. Red 3 and blue 2. One ball is taken at random from the bag and is not replaced. It is without replacement experiment. If this ball is red, another ball is taken at random from the bag and is not replaced. This process is repeating until a blue ball is taken from the bag. Part of the tree diagram that represent these outcomes is drawn below. Complete the tree diagram. So when we pick the first ball, we have 2 options. Either the ball will be red or blue. So we have 2 branches in the tree diagram. The probability of red is 3 over 5 written on here, and the probability of blue is 2 over 5. For the second ball, we also have 2 options. Either the ball will be red or blue. As the experiment is without replacement, now we have total 4 balls. Out of these 4 balls, we have picked 1 ball red already, so we have 2 red balls. So 2 over 4. And the blue, there are total 4 balls, and out of the 4, still we have 2 blue balls in this first part. As in the question, if this ball is red, another ball is taken. So when we pick the ball, if the ball picked is red, so we will continue the process. If it is not red, we will stop there. So that's why there will be no further branches from this blue ball. Now if the second ball is red, we will continue the process. And if the second ball is blue, we will stop over there. So there will be further 2 branches from this second red ball. Now we have picked 2 balls out of 5. Now we left 3 balls. Total 3 balls, and out of these 3 balls, we have picked 2 red balls already. So we have left 1 red ball. So the probability of red now is 1 over 3. And if this third ball is blue, so there are total 3 balls left, and out of these 3, still we have 2 blues because we haven't picked any blue in this path up till here. Now in third, this is again red ball, so we will continue process from here. Now we have 2 balls left, And out of these two, we have picked all the red ball in the previous, in this ball. One red over here, one red over here, and one red. We have already picked 3 red balls. So we have left 0 red ball. In here, we also have total 2 balls, and out of these 2 balls, we haven't picked any blue ball on this path. So we still have 2 blue balls. So the probability of this blue is 2 over 2, which is 1. So we have completed the tree diagram. Now find the probability that the second ball taken is blue. So this is second blue ball. This comes on the path, this path, that is red and blue. Just multiplying the probability in this path, 3 over 5 times 2 over 4, the final answer is 3 over 10. Now find the probability that a blue ball is the second or the third ball taken. If the blue ball is the second, so it will be the case red blue, or the third ball, then it will be the case of red blue. We have already found this probability red blue in the here 3 over 10. So whenever there is an or, it means plus. So in this path, the red has probability 3 over 5 times 2 over 4 times 2 over 3. And after this calculation and simplification, the final answer is 1 over 2.